During the exam for the Cloud Architect certification, some of the questions may refer you to a case study that describes a fictitious business and solution concept to provide additional context to exam questions. For the examination, these case studies are very important. If you know these case studies in detail and their possible solutions, you could potentially save 50% of time during the exam. So let's look at these case studies in detail. The first one is EHR Healthcare. EHR Healthcare is a leading provider of electronic health record software to the medical industry. EHR Healthcare provides their software as a service to multinational medical offices, hospitals, and insurance providers. It's a cloud architecture for on-prem to cloud migration solution and scale kind of problem. The second one we'll look at is the Helicopter Racing League. Helicopter Racing League is a global sports league for competitive helicopter racing. Each year, HRL holds the World Championship and several regional league competitions where teams compete to earn a spot in the World Championship. HRL offers a paid service to stream the races all over the world with live telemetry and predictions throughout each race. This one is a cloud AI and ML telemetry and streaming kind of problem. TerramEarth. TerramEarth manufactures heavy equipment for the mining and agricultural industries. They currently have over 500 dealers and service centers in 100 countries. There are 2 million TerramEarth vehicles in operations currently, and they see 20% yearly growth. Their mission is to build products that make their customers more productive. This one is a cloud automation operations and an API ecosystem kind of case study problem. Mountkirk Games makes online session-based multiplayer games for mobile platforms. They have recently started expanding to other platforms after successfully migrating their on-premises environments to Google Cloud. Mountkirk Games is building a new multiplayer game that they expect to be very popular. This one is also a auto scaling and sort of a gaming analytics problem. Now let's look at each one of these use cases in much greater detail with their possible solutions. So we'll start with EHR Healthcare. In terms of its background, electronic health record software to the medical industry. It provides software as a service to multinational medical offices, hospitals, and insurance providers. Its use case is EHR Healthcare's business has been growing exponentially year over year, need to scale environments, adapt disaster recovery plan, and roll out new CD capabilities. Google Cloud has been chosen to replace their current co-location facilities. Their current state is, in terms of environment, they have multiple co-location facilities. The lease on one of the data center is about to expire. The applications they have is the web-based application. Many of them run on a group of Kubernetes clusters. Data is stored in MySQL, MS SQL Server, Redis, and MongoDB. EHR is hosting several legacy files and API-based integrations with insurance providers on premises, which is to be replaced over the next several years. Monitoring is done via open source tools, and email alerts are often ignored. Their future state requirements, they're looking from business point of view is that to onboard new insurance providers as quickly as possible, provide a minimum 99.9% availability for all customer-facing systems, provide centralized visibility and proactive action on system performance and uses, increase ability to provide insights into healthcare trends, reduce latency to all customers, maintain regulatory compliance, decrease infrastructure administration costs, make predictions and generate reports on industry trends based on provider data. Their technical requirements are maintain legacy interfaces to insurance providers with connectivity to both on-premises systems and cloud providers. Provide a consistent way to manage customer-facing applications that are container-based. Provide a secure and high-performance connection between on-premises systems and Google Cloud. Provide consistent logging, log retention, monitoring, and alerting capabilities. Maintain and manage multiple container-based environments. Dynamically scale and provision new environments. Create interfaces to ingest and process data from new providers. Their executive statement is that their on-premises strategy has worked for years, but has required a major investment of time and money in training their team on distinctly different systems, managing similar but separate environments, and responding to outages. Many of these outages have been a result of misconfigured systems, inadequate capacity to manage spikes in traffic, and inconsistent monitoring practices. They want to use Google Cloud to leverage a scalable, resilient platform that can span multiple environments seamlessly and provide a consistent and stable user experience that positions them for future growth. Now, how would we approach this problem? So if you look at the case study, there's different bits and pieces that points you towards its integration, how the application is managed, how they monitor it, and how they can provision similar services over and over again. So if we break it down into these categories, so let's look at it from infrastructure point of view. They should use Google's IaaS and PaaS solutions for data centers. They should try to use global VPC, multi-regional replication for disaster recovery. They should set up a hybrid connectivity with cloud interconnect, which gives them 99.99% uptime SLA. They should use cloud VPN. And then they should look at dedicated interconnect for high performance connection between on-premises and GCP, because this has been called out multiple times that they are looking at a good connectivity to both on-premises systems and cloud providers. In terms of the applications, they should look at Kubernetes deployment to deploy all of the different group of Kubernetes clusters that they are using. So look at using Google Kubernetes Engine. Additionally, what they could look at is hybrid cloud architecture, which is to have Anthos as in cloud and on-premise container-based environment management and integration. So they can manage all of the Kubernetes clusters through single pane of glass. Then in terms of the API integration, the future API-based integration, they can look at Apigee as an Apigee or ApigX as an API management and proxy management solution. For predictions, they should look at AI platform or the Vertex AI, which is the new release, as an end-to-end machine learning lifecycle. Data ingestion, they should utilize PubSub for the streaming and cloud storage for batch. They can use Dataflow or Cloud Composer. Dataflow to have a unified process to ingest streaming data as well as batch data. Cloud Composer, which is based on Apache Airflow, to orchestrate all of these jobs. Databases, they can migrate MySQL and MS SQL to Cloud SQL. The Redis, the alternative could be Cloud Memory Store. MongoDB, they can use Cloud File Store. In terms of monitoring, cloud monitoring, they can use cloud monitoring for alerts and notification, charts and dashboards, cloud logging. They can use it for automatically ingesting audit and platform logs, manage retention and policies. Now, one of the things they called out multiple times is they want to be able to provision similar infrastructure over and over. So they can use Terraform for infrastructure as code, use cloud source repositories for storing the source code, use Cloud Build for deployment and orchestration, use Artifact Registry for container images. Now let's look at the second one, which is the Helicopter Racing League. In terms of its background, it's a global sports league for competitive helicopter racing, world championship, and several regional league competitions. HRL offers a paid service to stream the races all over the world with live telemetry and predictions throughout each race. Their use case is migrate existing service to a new platform to expand their use of managed AI and ML, deliver serving of the content, real time and recorded, close to users, particularly in emerging region. Their current state solution, it's a public cloud first company. Video recording and editing is performed at the racetracks, and the content is encoded and transcoded where needed in the cloud. Enterprise grade connectivity and local compute is provided by truck mounted mobile data centers. Their technical current state is existing content is stored in an object storage service on their existing public cloud provider. Video encoding and transcoding is performed on VMs created for each job. Race predictions are performed using TensorFlow running on VMs in the current public cloud provider. In terms of future state requirements from business point of view, HRL owners want to expand their predictive capabilities and reduce latency for their viewers in emerging markets. Their requirements are support ability to expose the predictive models to partners, increase predictive capabilities during and before races, for race results, mechanical failures, and the crowd sentiment, increase telemetry and create additional insights, measure fan engagement with new predictions, enhance global availability and quality of the broadcasts, increase the number of concurrent viewers, minimize operational complexity, ensure compliance with regulations, create a merchandising revenue stream. Their technical future state requirements are maintain or increase prediction throughput and accuracy, reduce viewer latency, increase transcoding performance, create real-time analytics of viewer consumption patterns and engagement, create a data mart to enable processing of large volume of race data. Their executive statement is their CEO wants to bring high adrenaline racing to fans all around the world. They listen to their fans and they want enhanced video streams that include prediction of event within the race. Example, overtaking. Our current platform allows us to predict race outcomes but lacks the facility to support real-time predictions during races and the capacity to process season-long results. Let's look at the possible solutions that we can provide. Now, as part of the requirement, I think the major part that's been called out is to be able to stream uh, race data back to the live stream is one of the primary requirements. So let's look at different solutions that we can provide. So in terms of the transcoding, their transcoding basically happens on VM. So video encoding and transcoding is performed on VMs created for each job. What they can do is they can use preemptible instances for VMs-based encoding solutions. But at the same time, they should look at containerizing the encoding solution and manage using Kubernetes engine because that will take care of scaling and distributing it all over the world. The TV box telemetry, they should look at App Engine to be able to basically ingest that telemetry data, PubSub for messaging, Dataflow for ingesting or doing ETL as a unified model for batch and stream, BigQuery as a big analytical solution, Cloud Composer to orchestrate events, and then cloud monitoring to increase telemetry and create additional insights. In terms of live video latency, they should use high availability configuration of Cloud VPN for connectivity between mobile data centers and Google Cloud. Use Cloud CDN for delivering content with speed, efficiency, and reliability close to the users. And especially because this is one of the things that's been called out is that they want to be uh, serve the content very close to the user and particularly in emerging region. So with Google's point of presence and its network availability in most of the region, Cloud CDN is a really good solution to deliver content very close to the user because it traverses within Google's own network. Use cloud storage with multi-regional buckets to serve contents. Use Perfect benchmarker to get visibility into metrics like latency, throughput, and jitter. And this is very important. You can use this benchmarker uh, which is a very good way to actually get complete visibility if you are getting the latency, throughput, or if there is a jitter. Google Cloud also offers Network Intelligence Center for comprehensive and proactive monitoring, troubleshooting, and optimization capabilities. In terms of AI and ML, they should look at use AI platform, which is the Vertex AI, for predictive efficiency and to support end-to-end machine learning lifecycle. Use TensorFlow deep learning VM instances. So the TensorFlow, which is running on the VM, rather than they can use the packaged TensorFlow deep learning VM instances for race predictions. Analytics should use BigQuery as a data mart because that was one of the technical requirement. Create a data mart to enable processing of large volume of race data. Use BigQuery as a data mart for processing of large volume of data. Use Looker for embedded analytics. And then use BigQuery streaming API and ML solution can create additional insights for increasing fan engagements. I hope this was helpful. Let's look at the next case study, which is TerramEarth. Now, in terms of the background of TerramEarth, it's a mining and agricultural equipment manufacturer. They have 500 dealers and service centers in 100 countries. Their use case is 2 million vehicles and projected 20% yearly growth. Vehicles collect telemetry data from many sensors during operation. A small subset of critical data transmitted in real time from vehicles to facilitate fleet management. Rest of the sensor data is collected, compressed, and uploaded daily at home base. 200 to 500 megabytes of data generated by each vehicle every day. Their existing technical environment is TerramEarth's vehicle data aggregation and analysis infrastructure resides in Google Cloud and serves clients from all around the world. A growing amount of sensor data is captured from their two main manufacturing plants and sent to private data centers that contain their legacy inventory and logistics management systems. The private data centers have multiple network interconnects configured to Google Cloud. The web front end for dealers and customers is running in Google Cloud and allows access to stock management and analytics. As a future state, their business requirements are predict and detect vehicle malfunction and rapidly ship parts to dealership for just-in-time repair where possible, decrease cloud operational costs and adapt to seasonality, increase speed and reliability of development workflow, allow remote developers to be productive without compromising code or data security, create a flexible and scalable platform for developers to create custom API services for dealers and partners. Their technical requirement is to create a new abstraction layer for HTTP API access to their legacy systems to enable a gradual move into the cloud without disrupting operations. Modernize their CI/CD pipelines to allow developers to deploy container-based workloads in highly scalable environments. Allow developers to run experiments without compromising security and governance requirements. Create a self-service portal for internal and partner developers to create new projects, request resources for data analytics jobs, and centrally manage access to the API endpoints. Use cloud-native solutions for keys and secrets management, and optimize for identity-based access. Improve and standardize tools necessary for application and network monitoring and troubleshooting. Their executive statement is their competitive advantage has always been their focus on the customer, with their ability to provide excellent customer service and minimize vehicle downtimes. After moving multiple systems into Google Cloud, they are seeking new ways to provide best-in-class online fleet management services to their customers and improve operations of their dealerships. Their 5-year strategic plan is to create a partner ecosystem of new products by enabling access to their data, increasing autonomous operational capabilities of their vehicles, and creating a path to move the remaining legacy systems to the cloud. Now, let's look at how we can provide them different solutions for the different use cases. Now, again, there's a lot of things being asked here, from data replications to how the vehicle, their uh, the equipment should actually connect to Google Cloud. How should they do their operations? And there's a big focus on moving towards API ecosystem. So let's look at it from different categories. In terms of the data replication, they can stream the critical data from vehicles to cloud big table to drive analytics in real time. So the vehicle collects telemetry data, the small subset of critical data, which is transmitted in real time. The flow could potentially be is sensor device to HTTPS gateway device to pub sub to data flow to bigtable, and that can be pushed on to GKE for application and presentation. BigQuery partitioning by timestamp for home-based uploads and unified analytics. So taking care of the small subset for the real-time predictions, as well as the rest of the sensor data, which is uploaded daily when they connect to their home base, that can be ingested directly into BigQuery. Data processing, they can use Dataflow for serverless unified batch and stream ETL. ML Engine or Auto ML tables use Vertex AI for machine learning lifecycle to forecast anticipated stock needs to assist with just-in-time repairs. Vehicles, when it's home-based connected, use the Cloud IoT Core, IoT devices to Cloud PubSub, from where Cloud Dataflow can pick it up and upload it to cloud storage, which can be used in BigQuery for further analytics. Cloud operations. This was one of the business requirement that decrease cloud operational costs and adapt to seasonality. So there are a series of actions that they can take. They can try to use managed and serverless services. They can use Network Intelligence Center for monitoring, verification, and optimization, because there is an element of remote developers to be able to be productive without compromising code or data security. They can use the Network Connectivity Center and Security Command Center for holistic security view. They can use cloud monitoring for real-time visibility and Google Cloud KMS for key management, because this was one of the requirements that they use uh, the cloud managed key solutions. Now, there was a lot of focus on API ecosystem in terms of creating a new abstraction layer for HTTP API access, creating a self-service portal, uh, and uh, and create a flexible and scalable platform for developers to create custom API services. So they should definitely look at Apigee or the new version of Apigee, Apigee X, to manage and monitor APIs. Apigee is a very robust API management platform. Uh, it can create an abstraction layer to connect to different interfaces. Now, the next question, statement, technical requirement was to create a self-service portal for internal and partner developers. Now, that's a direct use case for a developer portal. The concept of a developer portal is an interface where the developing company, the partners, they can all come together and utilize the same source of truth. To interact with different systems in the form of an API. So Apigee Developer Portal, it lets you build a self-service portal for internal and external developers. The partners can come and build apps on top of the APIs exposed by different enterprises. And then you can deploy those APIs on Google Kubernetes engine behind uh, um, Google global load balancing to get the kind of scale to interact with different partners with the ecosystem, in this case with dealers. Now, another requirement was to modernize all CI/CD pipelines to allow developers to deploy container-based workloads. So for CI/CD, they can look at cloud source repositories, which is an alternative of GitHub on Google, Artifact repository, to store the deployable artifacts on Google Cloud. And then Cloud Build, which takes care of CI and CD for CI/CD operations. Additionally, they can use Spinnaker to deploy on Kubernetes with blue, green, and canary sort of deployments. Uh, Spinnaker with Cloud Build, it's one of a very well-known prototype for deploying Kubernetes. In terms of the remote workforce, they can use G Suite with integrated Cloud IAM. With G Suite, it becomes really easy to create different groups with integrated IAM controls in terms of what services they can access, and also to integrate it with different projects within Google Cloud. It becomes very easy. And also identity-based proxy, uh, creating different identities, uh, matching it uh, to the Active Directory. All of these identity-based solutions, become really easy. They can use cloud data loss prevention for sensitive data protection. So Cloud DLP is a very important tool. Additionally, uh, to make it easier for them to interact with a lot of data, is they can use connected sheets with BigQuery to collaborate with integrated security controls. So this is a very handy tool, and especially if you're working with ecosystems like dealers, um, them having an IAM policy and to be able to work out of their sheets to connect to BigQuery and work with a lot of numbers, it's a really good advantage, and it's a really good service from Google. So I hope this is useful. Let's look at the next one. So the fourth one and the last one is Mountkirk Games. So the background of Mountkirk game is it's an online session-based multiplayer games maker for mobile platforms. They have started expanding to other platforms after successfully migrating their on-premises environments to Google Cloud. Their recent endeavor is to create a retro-style first-person shooter game that allows hundreds of simultaneous players to join a geo-specific digital arena from multiple platforms and locations. A real-time digital banner will display a global leaderboard of all the top players across every active arena. Their use case is building a new multiplayer game, which is expected to be very popular, deploy games backend on Google Kubernetes engine to scale rapidly, and use Google's global load balancer to route players to the closest regional game arenas. In order to keep the global leaderboard in sync, they plan to use a multi-region spanner cluster. Their existing technical environment is they have recently migrated to Google Cloud. 5 games came across using lift and shift virtual machine migrations with a few minor exceptions. Each new game exists in an isolated Google Cloud project nested below a folder that maintains most of the permissions and network policies. Legacy games with low traffic have been consolidated into a single project. There are also separate environments for development and testing. Their business requirement is support multiple gaming platforms, support multiple regions, support rapid iteration of game features, minimize latency, optimize for dynamic scaling, use managed services and pooled resources, minimize costs. Their technical requirements are dynamically scale based on game activity, publishes scoring data on a near real-time global leaderboard, store game activity logs in structured files for future analysis, use GPU processing to render graphics server-side for multi-platform support, support eventual migration of legacy games to this new platform. Their executive statement is their last game was the first time they used Google Cloud, and it was a tremendous success. They were able to analyze player behavior and game telemetry in ways that they never could before. This success allowed them to bet on a full migration to the cloud and to start building all new games using cloud native design principles. Their new game is their most ambitious to date and will open up doors for them to support more gaming platforms beyond mobile. Latency is their top priority, although cost management is the next most important challenge. As with their first cloud-based game, they have grown to expect the cloud to enable advanced analytics capabilities so they can rapidly iterate on our deployments of bug fixes and new functionality. So if you look at these executive statements, there's primarily 3 things that they are looking for. Scale, so basically the latency, cost, and advanced analytics. So let's look at some of the possible solutions that they can look at. Since they are keen on using the multi-region spanner cluster, they should use Cloud Spanner, which is a sort of a database with relational features, but it provides horizontal scaling and 99.999% availability across regions. They should look at Google Kubernetes Engine to deploy games backend as microservices. Google Load Balancing for worldwide seamless auto-scaling. PubSub Dataflow and BigQuery for stream analytics. PubSub to um, receive the stream data, Dataflow to process that streaming data, and BigQuery to do the analytics on top of it. They can look at Looker for player insights and analytics. As one of their technical requirement was to use GPU processing to render graphics server side for multi-platform support, they can look at GPU's hardware accelerators on Google Kubernetes Engine. They can use cloud data stored for transactional game state Cloud storage for storing game activity logs and analyzed using BigQuery, because they store game activity logs in a structured file for future analysis. So the combination of cloud storage and access it from BigQuery uh, makes a makes a good solution. They can use Cloud PubSub for buffering of live and late data, Cloud Data Flow for bulk and stream processing. Now, these two are very important, that buffering of live and late data, and Cloud Data Flow, because of its windowing capability. um, it can actually ingest that data and numerate it in the right sequence. BigQuery for storage and analytics, which can also contain 10 terabytes of historical data. Now, when it comes to the cost part of it, is they should look at managed and serverless services for dynamic scaling, minimal cost, and operations. Cloud operations metrics and APM functionality for proactive troubleshooting. Now, at the bottom, it's one of the sample gaming analytics platform reference architecture from Google. What what this basically says is, for any game you have real-time events and then you have a batch load. Typically, a real-time event you will ingest it through uh, in this example, you will ingest it through App Engine, or you can have a Kubernetes engine, depending upon what's the game logic, or what sort of volume you're running, and how many microservices you have. And then, and also from App Engine point of view, its App Engine has two different flavors. So standard and flexible, depending upon whether you are using uh, container-based logic. Then uh, that data can be fed to Cloud PubSub. This is where it can store live and late data, which data flow can pick up and stream it to BigQuery. Now, from the batch side, again, the batch upload will be done to cloud storage, which again, Cloud Data Flow can process and put it into BigQuery. Cloud Data Prep, it's a visual data preparation tool. So with a huge amount of data, you can use this tool to visually analyze different data sets. Then once the data makes it to BigQuery, you can use Google Data Studio, Looker, or a partner BI tools like Tableau, or uh, or the co-workers can actually directly access Google BigQuery. But there's another good important thing is by using the connected sheets. So where from Google Sheets you can actually analyze BigQuery data. So I hope this was useful. Every time you are looking at question based on cases, it's very important to find out the differentiating factor in the question, because there's a lot of time there are different ways to solve a problem, but there's something in the question will point you towards specific specific GCP services. Like for an example, it might say you're looking for a relational database, but then at somewhere it will tell you that whether they are looking for vertical scaling or horizontal scaling, and that's how you will come to Cloud Spanner. So this is very important to know how to approach a question and look for those hints. I hope this was useful. Thank you.